Cramer's rule. Okay, so finding the determinant of a matrix, the first thing I want to point out is actually not mathematical, okay? The first thing I want to point out is there's two ways that I can write the notation that lets you know I want a determinant. So notice here that on this top guy, this just looks like absolute value bars instead of my normal matrix box. That means go get the determinant. Okay, so those, what they look like absolute value bars, it means determinant. And then the second notation that you might see is where I keep the normal box, but I just put DET in front of it. It's only underlined because my iPad thinks I misspelled something. Okay, so that's all it is on that. So so there's two different ways that I could write down determinant. So the determinant of a 2 by 2, I'm always going to make you do this one analytically. I'm always going to make you do this one by hand. Always, always, always. Because it's easy by hand. But the 3 by 3, I'm always going to let you use the calculator on that one. Okay? So we'll go ahead and just follow the instructions here. Basically, want to multiply the diagonals and subtract. Always start with the top left box. Okay? Or the top left element. So walk me through the math on this. It's pretty simple, but what am I multiplying first? Okay, and then I'm going to subtract. What am I going to multiply next? 3 times -2. So an interesting comment is that determinant is always going to land you on a number. It's not going to give you a new matrix. It's going to spit out a number at you. Okay, so when you find the determinant of a matrix, and I'll explain in just a minute what it's used for. So, or maybe you could already tell me. So I have a -9 here plus a 6. So this is going to give me -3. It was? Oh, so you guys already did that one. Okay, good. But you didn't have to do number 2, did you? Okay. So what you're going to do is go ahead and enter this matrix into your calculator. Take a minute and enter it in. I haven't even found any good apps that do matrices, so I don't even have that to hand you. But you'll have your calculator on test day? Okay. Please don't forget it on test day. Do you have it entered in? Okay, so get out of that. Go back to your home screen. Go into the matrix menu and go under the middle column, the math column. And what's the very first thing you see in the math column? Determinant, DET. Okay, so go ahead and type that in. And whatever you named your matrix, A, B, C, whatever you named it, go ahead. You have to go back to the matrix menu and tell what matrix you want to find the determinant of. For the record, you can only find the determinant of a square matrix. You can't find the determinant of any matrix except for a square matrix. That's the only kind, okay? So, and then push enter. I am going on memory. I haven't seen this since fall of last year. Is it 10? My memory only remembers things that are absolutely unimportant. Now, you say, great, but what does that do? First thing I want to do is I want to show you what you would have to do if I made you do this by hand. Okay, just to kind of let you know that I'm being nice to you. Because I needed help with that. So what if you were going to find the matrix determinant by hand? What I would do is I would take these two columns and I would copy them again. So that would be a 2, 4, 2, and a 1. So you don't have to write this down. This is just something you can watch. And then what you would do is you would take this diagonal. It's a little bit large because that's going to run into some things. All right, so you would take this diagonal, you would multiply those numbers together. You would take this diagonal, you would multiply those numbers together. You would take this diagonal, you would multiply those numbers together. And then you would add those all up. Those three products you would add up. And then what you're going to do is you're going to take this diagonal and multiply those together. Take this diagonal, multiply. Take this diagonal, multiply. Add those three products together. And now you've got two big numbers, maybe big, maybe not big, but two numbers that you have come down to, and you're going to subtract those two. Okay. So I think you can tell by that it's somewhat tedious. Okay, way more tedious than just entering it into the calculator and allowing your calculators to do the work on that. All right, so that's how determinants work analytically. Won't make you do that though, except for the 2x2. Okay, so from the video then, Cramer's rule is the fifth way to solve a system of equations. And so I can solve by using determinants. So this is where the determinant concept comes into play, where I can, Cramer's rule says if you find three different determinants, it will give you the solution to your system. All right, so again, from the video, this first guy, I call it my original determinant, okay? This guy is d sub x, this guy is d sub y. So then let's walk through how to use Cramer's rule and how to use determinants to solve. And again, on your test, you'll have questions that say solve using Cramer's rule. You might be able to get the answer correct by using substitution or elimination or RREF. But I'm going to be looking at the work, and that's where the majority of the points are going to come from, is from the work from your Cramer's rule. All right, so according to the video, what is the matrix that I'm looking for first? In order to get the original determinant, what matrix am I looking for first?
Coefficients.
Okay, so let's take this specific example then, and let's write down what that would be. Okay. And then we're going to multiply, multiply, subtract. So my first bit of multiplying gives me -3. Minus my second bit of multiplying gives me 4. I'm subtracting, so you're right, this is a -7. So you just jumped ahead of me a little bit, which is fine. Okay, in order to find d sub x, what column gets booted? Nope. The x column gets booted. And what does the x column get replaced with? And what are those called? Constants. Okay, so the x column gets booted and gets replaced by the constants. So that the 3 and the 2 out of there. And so I'm replacing those two with a -4 and a -5. My y column, though, it's going to stay the same, and it was already a 2 and a -1. So your first multiplying gives you 4, and then I'm subtracting. My second multiplying gives me -10, and so these two together give me 14. All right, then we go to determinant sub y. So now what column gets booted? The y column gets booted, replaced with the constants. So then what is my new matrix that I'm going to find the determinant on? Yeah. So then my first multiplying minus -8, and -15 plus 8 is -7. Okay, so now I have these three determinants. What do I do with them? This is where Cramer's rule all boils down. What do I do with them in order to find my solution? Okay, so d sub x, which is 14, over, what did you say? Yeah, the original determinant, which was -7, that's going to be my x value. Yes, I will clean that up. And then for my y value, yeah, so -7 over -7. So then what is my solution answer? -2, 1. The cool thing about Cramer's rule, and I don't think I didn't give any examples of this, but I wouldn't mind putting one on the test. The cool thing about Cramer's rule is that it allows me to solve a 3-equation system pretty easily. So what I would do in that case is, let's walk through what a 3-equation system would look like. My original determinant is just going to be my coefficients, my 3x3 coefficients. Okay. D sub x, what's getting booted? The x column. So that whole entire x column gets booted, and what will those 3 numbers get replaced with? The constants. And when I go to find the determinant, what am I going to use to find the determinant? It's a 3x3. Use the calculator, right? And so that's the major difference between the example I just showed you and a 3-equation system. And then the y column is going to get booted, replaced by the x's, by the constants, I'm sorry. And then the z column is going to get booted, replaced by the constants. That'll be d sub z, determinant sub z, okay? And then I would just do the exact same math to find my 3 pieces of my coordinate as opposed to the 2 pieces of my coordinate. Does that make sense? There should be some of those in your homework, okay, that you can try. All right? Any questions? That's all I have for today, guys.